Which graph represents the polynomial function h of x equals x cubed plus 2x squared minus 4x minus 3? Chloe is here with her latest tips and tricks. She wants you to know that turning points equals the degree minus 1. Roots are where the function crosses or touches the x-axis. X-intercepts is when you set y equal to 0, and to find y-intercepts, you set x equal to 0. Now that we have Chloe's tips and tricks, let's go ahead and determine which one of these graphs represents this polynomial. So the first thing Chloe has in her tips and tricks is that the turning points is equal to the degree minus 1. So we can see that our degree in this problem is a 3. So if I take my degree of 3 and subtract 1 from that, I should have 2 turning points in my graph. So let's go ahead and look over here. This first one has a turning point where it's going up and then it starts to turn to go down. So there's one turning point. And then the second one when it's going down and then goes up. So this one will get a check because it does meet both of the criteria of having 2 turning points. Then this one over here also has 2 turning points where it's going up and down and then it switches from down to up. So this one will also get a check. So both of them so far have the right amount of turning points. Now the next thing to consider is let's look at our y-intercept. The y-intercept, all you have to do is plug in x equals 0. So everywhere there's an x, we're just going to switch it out with a 0. So if we look at our original problem, we have h of x equals x cubed plus 2x squared minus 4x minus 3. I am going to go ahead and put a 0 everywhere there is an x. So I'm going to really have 0 cubed plus 2 times 0 squared minus 4 times 0 minus 3. Now with this, 0 cubed is the same thing as 0. 0 squared is 0 times 2 is 0. 0 times negative 4 is a negative 0. And then we have that minus 3. And 0 plus 0 minus 3 equals negative 3. So therefore, when x equals 0, y equals negative 3. That's our y-intercept. So let's go ahead and see if they have, either of these have a y-intercept of 0, negative 3. So I look here, 1, 2, 3. This one right here is at 0, negative 3, and it looks like it's just below the line. So this one does not look like it will qualify for 0, negative 3. And this one right here, we have negative 1, negative 2, negative 3 right here. This one does look like it goes through it. Now, if you can't really tell, because that first one, it's kind of hard to tell, another technique you can do is to look at the x-intercept. Now the x-intercept is where y equals 0. So that means I would take h of x and replace this whole thing with a 0. So I'd have 0 equals x cubed plus 2x squared minus 4x minus 3, and I would have to solve for x. But that's going to be a little bit tricky because I could possibly have 3 roots, and I'm not going to go through all of that trouble. But another thing I can do is to pick a point and then for x and just plug it in and see what it gives me for y and see if that shows up on each graph. So I always like to look for x-intercepts. So on this graph here on the right, you can see that I have an x-intercept here at negative 3, 0. So if I plug in negative 3 for x and I get a 0 for y, then it's going to be this graph on the right. If I plug in a negative 3 over here, it should give me something very close up here to 14. So if I plug in negative 3 and get 0, I get the one on the right. If I plug in negative 3 and get about a 14, then I know I have the graph on the left. So I'm going to go ahead. Again, you can pick any x value. I just decided to pick negative 3. So if I plug that in, that'd be negative 3 quantity cubed plus 2 times the quantity of negative 3 squared minus 4 times negative 3 minus 3. Negative 3 cubed is the same thing as negative 27. Negative 3 squared times 2 is positive 18. Negative 4 times negative 3 is a positive 12, and then we have the minus 3. Negative 27 plus 18 plus 12 minus 3 does equal 0. So another point we have is negative 3, 0. And since this one does have that point right there, it gets a check. And this one over here does not have the point at negative 3, 0. Therefore, it gets an x. So the graph on the right is the graph of this function.